Okay, guys, real quick, if you missed the lab called the model of the three faults, I'm going to show you what the model should look like. You missed out on making this or watching me make this, but I will manipulate the model so you can get what you need in order to finish the lab. So, all right, the first one we had to do was with the normal fault. Okay, so for the normal fault, the instructions tell us to locate points A and B. There's B. All right, so we got A and B right here. Okay? All right, and then it says to move point B so that's next to point A. Right here. All right, and then it's telling us to observe what we see. As this has been put in this position. Okay, so let me see. I got to get B down a little bit here. All right, so I'm going to hold it in place. So this is what it would look like. This, the left side over here, D and A are higher than BC. BC has dropped in the normal fault, okay? So in the box, you need to draw this. Okay, so you can pause this video right here to do exactly that. And then the other thing is you have a question having to do with the river. Okay, so I'll show you what the river looks like on the top. Now take note of the fact that that river is flowing. Try to get this balanced here. It is flowing in this direction. It is flowing southwest. See, here's our compass. It's flowing southwest. So now this river is going to hit this wall of rock. So what is going to happen to the river? All right, so there's your question. There's no way that this can connect with the other part of the river now. What's going to happen to the river? All right, now I'm going to move on to the next one. So if you need to pause, you go ahead and do that. But I'm moving on to the next one. A thrust fault. For the thrust fault, and you do need to read this stuff. This is coming up in notes very, very soon. It says to locate point C and D in your model. Move point C next to point D. So we're in the same location. All right, so we found C and D. So I'm going to move them next to each other. Oh, look at this. Now, side BC has like a drop off, right? So you need to draw this. So you can pause it there, and then I'll flip it over so you can see what happens on the top. Because I got let me see what questions you're gonna have for the thrust. That means that BC was thrusted upward. You see that? It's thrusted upward. It's being thrusted up over that other side. All right. It's going to ask if or what happens to the road. Okay. So, now like I said, we now have a cliff here. This is a cliff. This is going to be a wall here. So, doing this the best I can. CD. Now we have a cliff there. The river would have turned into a waterfall there. What happens to the road? Okay. So there's that. All right, we have one more. The strike slip. The strike slip. For the strike slip, it says find points F and G. And then we're going to move F next to G. So these guys are here. All right, there's F, there's G. Move F next to point G. Like that. All right, so then you go ahead and draw that. Pause it if you need to so that you can get that drawing in. All right. One of the questions it's asking about is whether or not the layers are going to be continuous. One thing you got to take note of is that basically this F side has moved northward. The G side has moved southward. Okay. These side walls here, where the rock layers are, has not changed their location. Okay, they have not moved up. They have not moved down. The surface here has, however, shifted. And that's exactly what happens with the strike slip, right? One side moves one direction and the other moves the opposite. That's a strike slip like the San Andreas. So, there you go. I'll show you what it looks like on the other side, but it's kind of hard to tell with... All right, so see... So you can see that basically rock layers XYZ are still lined up. It's the top that has shifted. So there you go. Finish your labs. Turn them in, guys. All right. See you later.